Today our topic is to learn about coordinate geometry in XY plane. This is the topic we are going to start today. Yeah. Then in this case, first we have to understand that what do you mean by a parametric equation. So the topic is coordinate geometry in XY plane. We just learned the previous some related topic in our straight line and curve, straight line and the circle. Geometry in XY plane, right? So in this case, we need to understand about what do you mean by a parametric equation? Parametric equation. So up to now, we have already learned the Cartesian equations. Cartesian equations. Cartesian equations means the same equations where we have learned in our just like y equals to x squared plus 2x plus 1 or something. These are just like y equals to sine x, and we already learned y equals to e to the power x, those kind of equations or whatever the equations we are related with main variables x and y, that is called the Cartesian equations, which is already drawn in Cartesian coordinate system x and y plane. So whatever the graph, you can mark it in x and y just like this, whatever the graph, right? Then when you talk about the parametric equation means, in parametric equation, this main variables, what are the main variables in this one? The main variable over here is x and y. That means that these main variables are explained by another variable or triatic variable called parameter, right? That is what you mean by the parametric equation. So it's a equation where the main variables are explained by another term called parameters. Sorry, you have read it clearly. Parameters. Parameters, right? Okay, this is the simplest definition for a parametric equation. For example, we will get just like this. Suppose that you get, they have given the parametric equation x equals to 2. 2, it is a parameter. And y is equals to, we will get t squared. They have now after that, they used to give us the range and for t. T is varying from -3 to +3. Now that is what you mean by the parametric condition. So t is a parameter. Parameter variation, they should give what is the range where the parameter exists. How do you draw a graph for this kind of a parametric equation? Right. The drawing graph. Draw the graph explaining about parametric equation, right? This is the way of doing it. Initially, we will get the t values for this range. You can say -3, -2, -1, 0, 1, 2, 3. It's not compulsory to get it as range of 1 by 1. If it is like a critical situation, we just make the intermediate terms and identify it. For example, if you get some kind of critical situation come across, because we cannot looking for the coordinates, if you cannot identify what is the real situation in between these two, you can split into this. Suppose that if it comes in these two, you just split into another values like 2.5, 2.2, 2.12 like that. You can define it and you can get it. Let's see how to do it with it. So you can write this is x is equal to 2t, no? That is -6, -4, -2, 0, 2, 4, and 6. Then you can get the y values for the t squared. That is 9, 4, 1, 0, uh, 1, sorry, it's 1, 4 and 9. Now what happened here is that now it's turned up to the coordinates. The coordinates become minus 6, 9, minus 4, 4, minus 2, 1, 0, 0, 2, 1, 4, 4, and 6, 9. That's how it comes with it, right? Then we will just plot this. Make up a plot column there. Just, yeah, just then plot column. Then we can draw a diagram over here, just like this. Right. You know that the x value is varying from where to where? Minus 6 to plus 6. Y value is varying from 0 to 9. Right. So you can just get them like this way around. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then you can say 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? Okay. And this is y. Yes, y, and this is x. Then the first coordinate over here is minus 6. The coordinates here are minus 6, 9. Minus 6, 9. It's over here. So I'll just 2, 4, 6, 8, minus 6, 9, it's somewhere over here. Minus 4, 4. It's here, just to draw it perfectly. Minus 2, 1. It's here. 0, 0, 2, 1, 4, 4, and 6, 9. So you can say, you can draw this, just draw it nicely. My drawings are not that good because when you're drawing with this is not that good. So you can draw a graph like this, right? Okay, that's a way of drawing a what do you call that, equation explaining by the parametric expression, right? Now our objective is, while having this kind of a parametric equation, we should know how to convert into a Cartesian equation, because we are not much familiar with the parametric format of an equation. Only thing is that we should be able to convert into a parametric into a Cartesian equation. Right? Okay, so we just learn that part of it like this. Converting a parametric equation into a Cartesian equation, right? I'll get the first example itself, right? From here, let's try to understand this way. The equation is 2t and t squared. 2t and t squared. Yeah. Equation is x equals to 2t and y equals to t squared. They have given the range of t is equals to minus 3 to plus 3. Right, okay. Then what you need to do is put a step 1. This is the way of doing it. Step 1 is subject, sorry, the question, this is the way they used to give us the question, sorry. I just try to answer. I try to get the answer before we have to see whether what kind of question they ask. They can ask you, find the Cartesian equation in form of y equals to fx. That's format they will request, right? Okay. Then what you need to do is here. Then you can, the first step 1. Step 1 is put a subject t in one equation. Subject t in one equation. we use the method of elimination to do this process. Then you can, I'll get this one from equation number 1. I'll just label this one as 1 and this one as 2. From 1, subject t. That's the easiest way of subjecting t in this equation, subject t. So you get the answer. T is equals to x over 2. Hope you can understand how I get this right. Then what you need to do is substitute in the next one, step 2. Substitute in other equation. That's a simpler process of doing it. Then you can say, you can write substitute t equals to x over 2 in second equation, right? Okay, let's go ahead with this. Then you can say y equals to x over 2 whole thing squared. So the Cartesian equation become y equals to x squared over 4. From here you can get the answer for that. That's a way of getting the answer for this question. Right. That's a fact where we need to understand of conversion of a parametric equation into a Cartesian equation. But for the moment, we are not learning how to convert a Cartesian equation to parametric equation. It's a different approach. So we won't be learning that one. But for the moment, we should know how to convert a parametric equation into a Cartesian equation. Let's go ahead with a few more examples. Yeah. So this is kind of like same thing. Yeah, this one. X equals to ln t plus 3. So I'll get another example. X equals to ln t plus 3. Other equation is y equals to t plus, yeah, y equals to 1 over t plus y, right? Okay, for this example, there's another more thing they can ask you. They can tell you like this. This is another optional part they can ask you is state the range of the function. Sorry, state the domain of the function. So here the domain of the function, what you can get here is that we use this information to get the domain of the function. We know that t varying from where to where? T varying from minus t to plus t. Then according to that one, what are the answers for x? Then x varying from where to where? So you can say that it's a variation came from, if you just work out, it came from minus 6 to plus 6. So this would be the domain for this question, right? And according to the graph, you can find the range as well. So if you want to verify with the range, so you can just look into the graph. So you can say the the range is y values. It's starting from 0 and going up to 9. So if you want to get state the domain, and sometimes they can ask you the range as well. Range. So, the range, yeah. So if you want to get the range, this is the domain. And range become how much? But it's varying from, you can say y is in between where to where? 0 to 9. That's a way of getting this. Right. For this question, they mention over here, they have mentioned t is greater than minus 2. So here they have given another excessive addition, t is greater than minus 2. Okay, let's go ahead with this. From this equation, we need to get some kind of a, yeah, we have to subject t from one equation. Usually they want to find in terms of y equals, therefore no need of just subjecting from here is kind of like kind of confusing, and after that it would come up to this one would be little bit contradictory. Therefore we will just subject t from here. I'll just label this one as equation number 1 and equation number 2. So you can say from okay, right. Let's go to this one. So make the NA from 1. What you can get here is you can say This is x equals to ln t plus t input. So if you bring ln to other x, sorry, I just get this way ln t plus t. So you can take t plus t equals to how much? E to the power x. Therefore, you can say t is equal to how much? E to the power x minus 3. Then you can put it here. Then you can say substitute in 2. So you can say y equals to 1 over e to the power x minus 3 plus 5. So that is y equals to 1 over e to the power x plus 2 is the answer for that. Right. Okay. Then what you can get here is that is the equation for that. Right. Okay. Then if you want to find, so this case straightforward, you cannot find the domain because we don't know the behavior of this function. So we just, if you want, you can just plot this for a couple of figures and you can identify what is the behavior of the function. Right. So if you want to get the domain, you can get like this. Domain is, I will just put -2 and see whether what are the answers for this. Just you can see roughly, we can see what kind of figures you obtain, 0, 1, 2, like, and with that you can get some idea of what is the behavior of x. Right. Okay. So if we just do this, starting from -2, it goes 1 second. Yeah. Yes. Fx equals to ln plus 3 cross bracket starting from -2 and end from, we will get 2, 3 and step 1. If you just put it, you get this answer. But the -2 value is 0.69. This is 1.09, 1.38, 1.60, 1.79. So it's just like it's increasing function today. So you can say it just starting from 0.69 and it goes up like this. Therefore, you can write the domain is x is any real number and you can say x is greater than 0.69. And you can write, if they request you to find the domain, we have to plot for certain figures and see whether how does it comes. Right. Okay. Right. Okay. That's a way of, but here in this question, they didn't ask about the domain, but I just shown you how to find the domain for this. Right. Okay. Then just go ahead with this. They mentioned find the Cartesian equation for the each of the parametric equation given answer in form of y equals to fx. So what you need to do is here, x equals to t minus 2 and y equals to t squared plus 1. Other example is if you come across this x equals to t minus 2, x equals to t minus 2 and y equals to t squared plus 1. T squared plus 1. So for this case, what you need to do is you can subject t from this one. So I'll guess this equation as 1 and this equation as 2. So you can say subject t from equation number 1. So you can say t equals to x plus 2. Then you can say substitute in 2. Then you can write y equals to x plus 2 squared plus 1. So it's turned up to y equals to x squared plus 4x plus 4 plus 1 is plus 5. Like that you can get this answer. So that's a way of getting this kind of a question, right? Okay. So here now you can do these questions. Here also what they expect is find for each parametric curve, find the Cartesian equation. Find the Cartesian equation of the curve of y equals to fx given the domain in which the curve is defined. So same way you have to find out the domain and the range for it, right? Let's go ahead with this kind of question and see whether how to do it. X equals to 2 ln 5 minus t. So the question is put x equals to 2 ln 5 minus t, and they have given y equals to t squared minus 5. T squared minus 5, t is greater than 4. Minus 5, t is greater than 4, right? Okay. Then what you need to understand is, but initially we need to find the Cartesian equation. Cartesian equation you can write. I'll just get the first equation here and second equation here. So you can say subject x from first equation. So you can say x over 2 is equals to ln 5 minus t. Therefore, you can say 5 minus t is equals to e to the power x over 2. Therefore, you can say t is equals to 5 minus e to the power x over 2. So you can substitute over here. Substitute it in 1. So you can say y equals to 5 minus e to the power x over 2 whole thing squared minus 5. So you can say y equals to, if you just square this, it's turn up to e to the power x over 2 squared is x minus 10 e to the power x over 2. 25 minus 5 is plus 20. But this is the way of getting this answer. Then we need to find out the domain for this question. Now we can work out with the domain in this format. Okay, the domain we can just put some x, given some x values from here, and we can see whether what is the behavior of the function. So if I just put x starting from 4, x equals to, we can put 4, 5, 6, 7, so on. We will see whether here the range is a problem. 1 second. T is less than 4, not greater than 4. Yeah, that's it. Here it's not greater, it should be less than 4. This is less than 4. We can just work out with a couple of x answers and try to understand, because looking into this graph or this one, we cannot identify the domain properly. So it's turned up to 4, 3, 2, 1, 0, minus 1. We'll just go ahead and see whether what are these answers for this when t goes to this and x answers, right? So we can again use the function. I think you know how to enter the function exactly into your calculator. That is coming from mod with 7. We already learned how to do it. 2 ln 5 minus alpha x. Yeah. Starting from minus 1. Starting from minus 1 and ends from 4, step 1. Yeah. So this is turned up to put a minus, sorry, 3.58, 3.58, 3.2, 2.7, 1.3, and sorry, I just made a mistake. I just get into the other way around. T is equals to here, when minus 1 only 3.5, sorry, 3.5, and this is turned up to 3.21. This is 2.77, 2 ounce is 2.1, and this is 1.38 at T4. At 4, it's turned up to 0. So you can say from 4, it is increasing from 4 to the negative side. Therefore, you can say the domain x is any real number, and you can say x is less than 0, because you know that 0, it goes to the, sorry, x is greater than, sorry, x become, this is the x value, sorry, x value is gone up to 0, starting from 0, like this it goes on. So x is greater than 0. You can just like this. Then if you want to find the range, range also same way you can work out for this question. So you can get the t values 4, 3, 2, 1, 0, and minus 1. Then we can check whether what is the behavior of y values. how to find the y values? Either you can just put in this x value into this kind of function. It's kind of hard because like straightforward look into this one, we cannot identify a range is kind of hard. Therefore, I just use this parametric one to get this answer. T squared minus 5. So I'll just put t squared minus 5 into this. Squared minus 5. Starting from we have to start from 4. Sorry, starting from minus 1. I just put in from 4 and steps 1 by 1, right? Okay. Then make a workout at minus 1 answer is minus 4. At 0 answer is minus 5. 1 answer is minus 4. It's minus 1, 4 and 11. Now you can see it's just like a quadratic graph. Quadratic graph means it goes up to from a peak answer. It can come up to a lowest value, come at 0, minus 5, and it goes up like this. Minus 5 is the lowest value. So you can write range, y is any real number, and you can say y is greater than or equals to minus 5. Like that you can get this answer, right? Okay.